morning, students. For standard 10, I was taking triangle chapter. In this chapter, one last exercise is left. Before that, I'll tell you some important thing which is related to similarity of triangles. So, what is this important thing? In right angle triangle, if perpendicular is drawn from the angle from the vertex where it is 90 degree, then two triangles will be formed, and all the two triangles formed one, and the original triangle will be similar to one another. So that is the proof of that I will give you. It is a very important relation. That relation should be understood well because it will be applied for proving the Pythagoras theorem. So for that, let this triangle A, B, C, this is a right angle triangle where angle A is 90 degree. From here, if we drop a perpendicular on this, suppose it is D. Now there are three triangles. Triangle ABD, ACD and ABC. Three triangles are there. Then all these triangles are similar to one another. If we could prove it and we could show it, then this concept will be applied to prove the Pythagoras theorem. So we look at these triangles. Now, this angle, suppose we will name the angles. In triangle ABD and ACD, these two triangles we will look at. Let this angle be X. Let this angle be X and this angle be Y. Then you see, this angle plus 90 plus this angle. Sum of all these three angles is 180 degree. Here, this 90 degree plus this angle, right, is 180 degree. And big triangle ABC, this is 90, means X plus Y is 90 degree. From this relation, from this figure, what do we observe? That is X plus angle Y, that is equal to 90 degree. From triangle ABC. Triangle ABC, this is already 90 degree. This is X and this is Y. The sum of these two must be 90 degree, isn't it? Now we will see in triangle ABD. This angle we have to find out, right? This angle, what is the measure of this angle we will look at. Here, in triangle ABD, angle ABD plus angle BAD plus angle ADB, that is equal to 180 degree. Sum of these three angles will be 180 degree since it is a triangle. So angle ABD is X, therefore angle X plus BAD, that is BAD is not known, angle BAD is not known. Angle ADB, this angle is 90 degree, is equal to 180 degree. Therefore, angle X plus angle BAD is equal to 180 minus 90, that is 90 degree. Therefore, angle BAD, that is equal to 90 degree minus angle X, right? It is, suppose we write 2 and this one I will write 1. Is it clear? Because I have taken this triangle APD, the sum of these angles will be equal to 180 degree. This I have done. The angle BAD is 90 degree minus X. So from 1 and 2, therefore from 1 and 2, angle BAD, that is equal to angle Y. Because angle X plus angle Y is equal to 90 degree, therefore angle Y is equal to 90 minus angle X. So 90 minus angle X is Y, so BAD is Y. Very important. Now this angle is Y. Right? Now this angle plus this angle is equal to 90 degree. Now angle BAD plus angle CAD is equal to 90 degree. Angle BAD, angle CAD, sum is 90 degree because ABC is a right angle triangle. So BAD is angle Y, therefore angle Y plus angle CAD, that is equal to 90 degree. Therefore angle CAD is equal to 90 degree minus angle Y. So let it be question number 3. Therefore angle CAD is equal to angle X. That is from 1 and 3. Is it clear to all of you? So this angle is X and this is Y. So X, Y are 90 degree here, X, Y are 90 degree. So now we will talk about all these 3 triangles, whether they are similar or not. So first we will take the similarity of ABD and ACD. Now you see two angles of this triangle and 2 angles of these triangles are equal. So therefore these 2 triangles will be similar by the criteria of AA criteria of similarity of 2 triangles. This I have already taught to you. Therefore triangle BAD or ABD, triangle ABD is similar to triangle CAD. Triangle CAD. You see, angle ABD, CAD. So now while writing the triangle, those vertices should be correspondingly taken which have the same measure of angle. Are you getting my point? Then in that case what happens? It becomes quite easy to find the ratio of the sides. Suppose A of ABD corresponds to C because measure of angle of these 2 is same. A vertex of ABD corresponds to vertex C of ADC, right? So if I write A first, then for second triangle I will write C first. Then suppose we write D, ADB, right? Or ABD. So for B of ABD, it corresponds to A of ADC because measure is X, so corresponding vertex is A for this triangle, and third one, that is ADC for this vertex, right? And for this triangle is also 90 D, is also 90, so D is common in both, so that is why I have the CAD. It is very important. In that case what happens? It becomes very easy to write the ratio of the corresponding sides of 2 similar triangles. The 2 triangles are similar, the corresponding angles will be equal, and the ratio of the corresponding sides will also be equal. So to be comfortable in writing the ratio of the sides, if I have taken the corresponding vertices of those two triangles, then it becomes very easy to write the ratio. So these two triangles are similar by a criterion of similarity. Very nice. Now we will go for the second one. These two triangles are similar that we have shown. Now we will take ABD. Now triangle ABD. I'll see whether big triangle means ABC is similar to this triangle or not. You see, A for this triangle is Y angle. It corresponds to C of the big triangle ABC. So you write C first, triangle C, because A of this, that is Y, and for this big triangle ABC, Y is this angle. So A vertex corresponds to C vertex. Then B we have taken, so B is X, right? So X, it is common in ABC and ABD, so B will be as it is. And third one is D. D for this, ADC. D is 90 degree and this corresponds to A vertex for ABC. So CBA. Is it clear? It is very important. When we write the naming of a triangle, naming of the triangle is being done by writing the vertices, that is ABD, CBA, CAD and all. So for similar triangles, what do? We write the corresponding vertex. Corresponding vertex means where angles are, measure of the angles are equal. So this way, again the same thing by criterion of AA, because XY and XY for bigger triangle as well. Third one we will go for, we will take the triangle ADC. Triangle ADC. This triangle is similar to which that ABC. Whether it is similar or not, that we have to look at. We have taken ADC for big triangle ABC. A means this vertex for this angle corresponds, this triangle corresponds to this angle X. So for ABC, which is this angle, X angle, that is B. So first we will write triangle B. Corresponding vertex, very important. Corresponding vertex. A is X. So in this ABC triangle, X is B. So that vertex I have written. Then comes D. D is 90 degree. For this triangle is 90 degree. For big triangle it corresponds to A. The last one, it is common in big triangle also. So we will write C. See the difference. I have taken ADC and the big triangle ABC, whether these two are similar or not. So ADC, A vertex corresponds to angle X. Big triangle ABC corresponds to B. So A corresponds to B. B I have written. For D is 90 degree. In big triangle, vertex A is 90 degree. I have written A. This vertex C is common in both. So I have written C, and this is by AA criterion. So this is the, when in right angle triangle, from the right angle, if it is perpendicular, it is dropped on hypotenuse, then three triangles are there, two small triangles, one big triangle. All these triangles are similar to one another. This is very important relation, and with this relation we are going to prove Pythagoras theorem, which we have already studied, but proof by the method of similarity. We are going to take up Pythagoras theorem. Is it clear to all of you? So we will take care of it. We will see the proof, then we will go for the questions of the exercises. Right? So, before this, I have done the similarity of all the three triangles. If the original triangle is right angle triangle and perpendicular is dropped from the vertex where it is 90 degree. Now, Pythagoras theorem we will look at. This is six-pointed theorem. It is known as Pythagoras theorem also. In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. What does it mean? We will look at. So we will go for proof. So we should understand first the figure. Suppose it is A, B and C, it is a right angle triangle. So we know the side in front of right angle is called the hypotenuse, right? So BC is the hypotenuse and other two sides are AB and AC. So to prove what is to be proved? BC square is equal to AB square plus AC square. Right? So we will go for construction. Construction we will do. We will drop a perpendicular from here on the hypotenuse. Remember, just before this, I had done this kind of activity. So that is to be correlated. And let this point be D. Right? So draw a perpendicular from A on BC. I have brought perpendicular from A on BC. Let this point be D. Now we will look at the similarity of triangles. Now let this angle be X, let this angle be Y. So I have already done in the previous case. This angle will be equal to Y and this angle will be equal to X. Is it clear? Now, so all these three triangles ADB, ADC and ABC, all these triangles are similar to one another. Now we will go for proof. So we will take the triangles ABD and ABC. These two triangles we will look at. In triangle ABD and triangle, I have taken ABD, right? CBA will be the corresponding vertices and triangle CBA. I have taken ABD, this small triangle, and I have taken the big triangle, right? That is CBA. In triangle ABD and triangle CBA, ABD and CBA, angle BAD is equal to angle BCA is equal to angle Y. Angle ABD is equal to angle CBA is equal to angle X. Therefore, triangle ABD is similar to triangle CBA by AA criterion of similarity. By AA criterion of similarity, these two triangles will be similar. Therefore, ratio of the corresponding sides will also be equal. So, ratio of corresponding sides means AB upon CD. Therefore, AB upon CB is equal to BD upon BA. BD upon BA. This corresponds to this and this corresponds to this. Therefore, AB means B and AB both are same. So therefore, AB square, that is equal to CB into BD. Equation number 1. This relation. Now we will go for the big triangle, that is ABC and ADC. Right? In triangle ADC and triangle, for similarity, this A is X corresponds to B, for D corresponds to A, and C is common. See? Triangle ADC. See how to write the vertices. A of this triangle corresponds to which vertex? This triangle A. This corresponds to B of the big triangle. Previously, I have already told all those things. I am repeating. Remember this. Corresponds to B. And this D. D is 90 degrees. It corresponds to A. And C is common in both. Now, angle. For this angle, suppose CAD. Angle CAD is equal to CBA. Angle CBA, that is equal to angle X. Now, angle ACD. ACD is equal to angle, for big one, ACB. ACB is equal to angle Y. Therefore, triangle ADC is similar to triangle BAC. This is by AA criterion. These two triangles are similar, so ratio of the corresponding sides will also be equal. So we will see, because AC, so here AC corresponds to BC. So we will write AC upon BC is equal to DC upon AC. DC upon AC. Corresponding sides. Taking these two vertices one side, these two vertices another side, these two vertices one side, this is corresponding side, and taking these to one side, and this is corresponding side is BC. So since we want AC square, so we will see that in relation AC is there somewhere. So AC, these two we have taken AC, so corresponding is BC, AC upon BC. Now again AC we want, so AC in this over here, so DC upon AC. So with this we get AC square is equal to BC into BC. It is equation number 2. So these two equations we got. With the help of these two, we will prove this relation. Now, from equation 1 and 2, we will write from equations 1 and 2. AB square and AC square. We will add these two, right? So, AB square plus AC square is equal to AC square is AB square is CB into BD. So CB into BD plus CB into DC. CB into DC. From these two we will take CB common. We will get BD plus DC. BD plus DC is BC. So CB plus into CB is equal to CB square, or in the form of what was to be proved, accordingly I have to write then, or BC square is equal to AB square plus AC square, that was to be proved. So this was to prove, that we have done, and this is called the Pythagoras theorem. and this theorem will be applied for the numerical problems. Remember this, it's a very important theorem and very frequently at various places for various problems this will be used. Similarity, it is a very important chapter. Its application is very important. Various types of problems you will be getting, and you should be able to attempt all those questions effectively. For the sake of these things are required to be understood very well. Take care of.